In this video, I'm going to provide a solution to this problem. Okay, so we have 2 raised to x plus x equals to 20. Okay, so let's start. Okay, so let me keep 2 raised to x on my left hand side and send x the other side. Okay, we have 20 minus x. Okay, all right, now let me divide both sides. I want everything to go on my right, so I'll divide both sides by 2 raised to x. So we have this 2 raised to x. So we have 1 here equals to 20 minus x all over 2 raised to x. In case we're given 1 on c, it is the same as c raised to negative 1. So can I say 20 minus x times 2 raised to minus x? Yes, I can say that. Okay, to be able to solve these type of questions, you need to apply the Lambert W function. Okay, now with the Lambert W function, if we have something like so Lambert W function of, let's say, x, okay, e raised to x, the same as x. So Lambert W function of k times e raised to k, the answer is k. Okay, now you want to make this side, then the exponent here, equal in order to apply the Lambert W function. So we have something here, and the power here will be the same as that. So we need to add 20 to the power here. And how do we add 20? So I'll just multiply both sides by 2 raised to 20. So this side 2 raised to 20. Okay. All right. So going forward, I can apply indices here. So this was a multiplication. Therefore, I can add the powers. So 20 minus x. So this side will be 2 exponent 20 minus x. So look at what is here and then the power. They are equal. So my left hand side will be that. Okay. Now, before we can apply the Lambert W function, we need to do something here. Okay. Now, when you take e, then ln of something, the same as that thing. So these things are under natural log function. Okay. So e raised to ln of, let's say, box, the same as box. Now, we are doing this because we need to do something to this 2 here in order to perform the Lambert W function. Okay, so I'll just support this 2 here. Okay, so 20 minus x. So I'll write this 2 here as ln of natural log of 2 raised to 20 minus x. Now, when I go back, this ln raised to that will still give me this 2 raised to 20 minus x. So I've done nothing to it. Okay. All right. So let's apply something here. Now, in case we're given something like this, okay. So e raised to ln of, let's say, box raised to x, the same as e x ln of the box. Okay, so we can adjust this one. Okay, we can say that 20 minus x, okay, times e. So this one is a power rule. So we have 20 minus x. Then we have ln of 2. Okay, as simple as that. All right, we have 2 raised to 20 here. Okay, now let's observe something here carefully. Now you could see that the power here is 20 minus x ln of 2. Okay, but what is here is different from what is here. And before we can apply the Lambert W function, we have to make sure what is here is the same as what is here. Okay, so the power and what is in front of this, what is at the back of this must be equal. So what do we do? This one is missing here, so you need to multiply both sides by ln of 2. So I will say 2 raised to 20 times ln of 2. Then this side will be 20 minus x ln of 2. Then e raised to 20 minus x ln of 2. Okay, so we can go ahead, then take the Lambert W function on both sides. So we have Lambert W function. Now do same to this side. We have Lambert W function. Okay, so my left hand side will be W function of 2 raised to 20 ln of 2 equals to, so when you take Lambert W function, we have what is here, then what is there. So I will leave it 1. So we have 20 minus x, 20 minus x ln of 2. If we can do some cancellation, so we can write 2 to the power 20 as 2 to the power 16 times 2 to the power 4 ln of 2. So we have 20 minus x ln of 2. Okay, so we have 2 to the power 16 here times, so we can say 16 ln of 2 equals to that. Now, can we introduce e raised ln to this so that we take the w function here? Now let's try and see. So this one can be written as e raised to ln of 2 to the power 16 times 16 ln of 2 equals to 20 minus x ln of 2. Okay, so we can rewrite this one as 16 ln of 2 times e. So this one is a power rule, which will be 16 ln of 2. Okay, equals to 20 minus x ln of 2. So we have what is here, okay, then what is there being equal. So when we take w function of this, I will have it 16 ln of 2 equals to 20 minus x ln of 2. Okay, so this one is common to cancel, which will have is 16 equals to 20 minus x. Therefore, x is the same as 20 minus 16. So x is simply 4. All right, so that's the answer.